fresh water and like the water we drink.
Yeah, I mean, there was even a big issue with the rivers around Mount St. Helens getting choked with sediment, and people depending on those rivers for drinking water as well as for fishing and even on a commercial scale. So, I mean, that would probably be even more of an issue because it's all about the amount of that ash that would be erupted. So, I mean, if you get a chance, what you could do, in fact, you might even think of slipping this into your presentation, is going to YouTube and taking a look at some of the clips of the Mount St. Helens volcanic eruption, because that was a big ash producer, and some have predicted that when Yellowstone erupts that it's going to be, 1,000 times more ash than that. That at least that would give you some idea of both ash in the air as well as the rivers, because they'll show some of the video of the mud flows from that volcanic eruption. So at least you'll get an idea of what some of that looks like, and then think we'd have to scale it up so many times if it was the Yellowstone eruption.
So Yellowstone, it wasn't a super, it was just a volcano.
Mount St. Helens, yeah, it was just a typical, somewhat typical volcanic eruption for that type of volcano. So when I started out with the Hawaiian Island volcano, and then we talked about Yellowstone, Mount St. Helens, Mount Rainier, and those other volcanoes in our Pacific Northwest are sort of in between those two types of volcanoes. And yet Yellowstone is even so many times greater than Mount St. Helens. But if you go to those clips, you'll get a better idea of what a more, so I said that we consider the even though the Hawaiian volcano erupts almost constantly, one of the most peaceful volcanoes in the world. That's not the case for Mount St. Helens. We consider that a violent eruption. So, in fact, many books, introductory books in geology, don't really spend much time talking about supervolcanoes because they are so rare, and it's not likely that any of them are going to erupt anytime soon. So usually, if they're in an intro book like the one I use in class, there might be a single page on it. Very, very interesting topic, but at least at an introductory level, not one that we'd spend an awful lot of time on, because it's not likely that it's going to happen in terms of human lifespan, even the distant future. So that's why I say it should be on the top of your list of places to go, because there's no other place like it. It's not dangerous as long as you stay on usually they'll have a wooden boardwalk through the geyser basins. I mean, there's really no danger in going there and walking around the park. It's just, an awesome place to think, geez, I can't see it, but there's this giant blob of magma below me, and it's resulting in all of these hot springs and geysers. So, anything else? Does that help?
Yes, thank you so much. Yes.
Yeah, the other thing I just wanted to show you really quick is that as a geologist, not just a geologist in Yellowstone, but this is one of the most important tools for a geologist, which is a hammer, because the rocks really tell the story. How do we know that the eruption occurred 630,000 years ago? By collecting samples of the rock. So that's why you wouldn't use that in Yellowstone National Park, because it's against the law to sample rocks. But if a geologist is in an area, or he has permission from the government to take samples, that's one of the most important tools for a geologist. The other one is a compass, and this is a little more sophisticated than maybe a compass you've seen. Nowadays we use what, GPS?
Yeah.
Maybe even have GPS on your phone or
Yeah.
in your car. Well, geologists can't always count on a GPS. Even in your car, maybe sometimes you lose the signal, right? Well, a geologist doesn't want to have to worry about losing that and losing position, so geologists still oftentimes uses a compass like this. So these would sort of the average geologist, those would be the two most important tools. Pretty simple tools, but still very, very important tools.
Yes.
So, and you know, if you want, I wish I could find that map, but you can easily just, you know, go to a search engine like Google and type in Yellowstone National Park ash fall map, and you know, a bunch of different predictions all come up. They're color coded. For sure it was in this. Here it is. So here's the color code. So here we are, 1,000 millimeters thick. So that's what, a meter? Here's a meter stick. So this prediction, you know, even right around, so here's Yellowstone National Park right here.
Yeah.
And if we look at the color code, this map is predicting this much ash. So we'd have to have how many of these to reach the ceiling, which last time was 1,000 miles away from Yellowstone National Park. So this map is predicting perhaps, so what's the color for Milwaukee? What would you say? Orange?
Yes.
Which is 10 to 30, which is what? There's 10 per, so 1 to 3, so 2.5 centimeters per inch. So as I said, maybe an inch in Milwaukee of ash. The issue is though, that you don't want to breathe that stuff.
Yeah.
So if you look at some of those videos of the Mount St. Helens, you'll notice people are walking around with surgical masks, or you know, maybe a mask you would wear if you have allergies. I wear them during certain times of the year when I cut the grass because I have allergies, or even going as far as these respirators that you might have seen that come over your entire face.
It looks like the very tip of Texas and Florida don't seem like they
Would get anything?
But
Yeah.
I think they actually will because
Yeah, it's an
so
interesting
powerful.
point.
Yeah.
Yeah, I'm not sure why they
Mm-hmm.
put the map together. But if you go to one of the search engines, you'll see a variety of different color coded, you know, because they don't know.
Yeah.
And it could be the next eruption occurs and it's, you know, relatively minor, and you know, that's it.
1,000. That's a lot of ash.
Yep.
And there's no way to prevent this?
Well, right now there isn't any way to prevent it, but that's not to say that in the future we wouldn't come up with
Yeah.
some way to. Yep.
Maybe you guys will figure it out.
Yeah.
This will be the very start of.
I mean, that's what I tell my students.
Yeah.
Even today we were talking about climate change. I don't know if you've talked about that yet
Yes.
in class,
Mhm.
but I mean, I really think it's your generation that's going to figure out how to turn the tide on global warming. So, I mean, who's to say that, you know, in the next your generation that you might not figure out some ways to minimize the impact of the erupting volcano.
And if you're looking for the solution to this, you might find the solution to something else.
Mhm.
Yes.
A lot of times it
Yep.
happens that way.
Yeah, that's human innovation, right? We set out to solve one problem and we find out that in doing that we solve a lot of other problems along the way. So,
Thank you.
Thank
yeah,
you
you're
so
welcome. It
much.
was nice, yeah.